Hello, everyone. Welcome. This is part one of a two-part webinar series we're going to do on Windows Management Instrumentation. This is the detection series, part one of two. And yes, this will be recorded. So for those of you who are not able to join us or have to duck out early, we will be recording this. We're also going to be taking questions. So please use the Q&A function, and we'll try to get to those questions time permitting. So who is Red Canary? What do we do? Well, Red Canary is a provider of managed detection and response, as well as many wonderful open source tools and education for the information security community. Who are we? Who am I? I'm Greg Bailey, the Director of Incident Handling here at Red Canary. We've got some wonderful panelists with us. Christopher Glyer is the Principal Software Engineer, Cloud Security R&D at Microsoft. We also have Jamie Williams, Lead Cyber Adversarial Engineer from MITRE, and a special guest appearance by our own Matt Graber, Director of Threat Research. So let's get going here. The agenda looks like this. We're going to talk about Windows Management Instrumentation, what it is, how adversaries use it, and then we're going to take a little look at the history of its detection. So some malicious usage as well as key research that has led up to where we are today. And there are a lot of different ways that adversaries use WMI. We're going to focus in on today persistence. We could spend many, many hours talking about the various adversarial usage of WMI. We're going to focus in on persistence, how we can identify it, and some examples of WMI persistence in the wild. And then the last thing we're going to do, Matt's going to come in and he's going to kick off our interactive detection. So we have a challenge for you all. I'll let Matt introduce that at the end of the webinar for tomorrow as well. You can win a free t-shirt, so you might want to stick around for that one. All right, so really quick, what is Windows Management Instrumentation? It's an administrative tool. So MITRE describes it as this, a Windows administration feature that provides a uniform environment for local and remote access to Windows system components. It relies on the WMI service for local and remote access, as well as SMB and RPC. So we are going to move forward here and talk about the various ways that attackers use WMI. From my perspective, as a red teamer and a former pen tester, I like to use WMI for remote code execution and various uses of that nature. But Jamie, why don't you tell us a little bit about how adversaries specifically are using WMI and the various APT groups?
Awesome. Thanks, Greg. So like you said, WMI has a pretty wide interface in terms of what it's capable of. But, our most common abuses are obviously going to be those execution. So looking at the techniques that are relevant here, we see, WMI. I think Brian already shared that in chat if you want to check that out. But that technique is going to be solely focused on adversaries using a WMI interface in order to execute, arbitrary commands and payloads locally or remotely. The local execution we map to the execution tactic technique WMI, and then that remote X part is going to ride over either DCOM or WinRM as the kind of the service that carries execution to the remote host. But as you said, our spotlight in the day is focusing on, something that's gaining a lot of traction recently is adversaries using WMI for persistence. So, I'll save, Christopher Glyer is going to go through this a lot more detail later. I'll spare the details there. But basically, long story short, WMI is able to subscribe and listen to system events and actually invoke execution on behalf of, triggers or things that they notice happening in that environment. Can I get a slide flip, please? Yep. But as you said, WMI is very much a Swiss Army knife. We have a couple techniques that are specifically mapped to WMI mechanics, but like you said, there's so many interfaces and so many methods that there's a wide spectrum of adversary behaviors that are possible through this interface. So I highlighted a couple here, and this definitely isn't everything. This was just the things that kind of pointed out to, or kind of stood out to me, as well as, very common use cases. But, WMI is built to be, like you said, that very generic and very practical sysadmin tool. So, it has access to a lot of system data. So adversaries are able to perform various types of discovery and reconnaissance through WMI, as well as hiding data and manipulating system functions and system, repositories, such as, things in the registry. Or, one of my most interesting use cases is WMI is very much associated with, an impact technique, specifically inhibiting system recovery, actually triaging and finding system backups and deleting those shadow shadow volume copies so that, your systems are, unable to reboot and actually restore themselves. Like you said, looking at what adversaries actually use WMI, I thought I was going to list them all here, but that would be a slide in itself. There's such a wide spectrum of adversaries, both software and groups, that are associated with malicious WMI interaction. But the interesting thing is kind of diving through this, and we talked about this in one of our pre-chats, is there's the spectrum of adversaries isn't, kind of boiled down or centralized to one particular type of group, in terms of what they're doing, in terms of, like I said, impact versus data espionage, as well as sophistication. We see, kind of trivial things such as like coin miners and just commodity malware, even like red team tools like Cobalt Strike and Empire. Those have WMI embedded within them, some feature or functionality, as well as some of the most complex malware samples we've seen to date. Things like, Olympic Destroyer, not Petya, and even the most recent SolarWinds, espionage has included a lot of WMI artifacts that are very complex and very detailed. So, this is really something that, is almost universal across adversaries in terms of their abuse. Can I get one more slide, please? And then, just think about why. Like, why are adversaries abusing this? Well, first and foremost, living off the land. It's something that as an adversary coming in, they know it's, likely going to be enabled. It's likely going to be present, but also it's an opportunity to hide in plain sight. The usage and, the abuse of adversaries doing things in WMI isn't going to necessarily stand out to a defender. It's something that, is probably already native on the system. A lot of, benign and legitimate applications are already using WMI. So, WMI in itself is not going to be a flag that something bad's happening. Everything beyond that is it kind of really gets into the down and dirty and details of WMI, starting with, WMI is really great in, kind of attacking how defenders think about finding adversaries. One of my favorite things from the APT-29 emulation plan that we released last year was how APT-29 dumped credentials, and getting to that second bullet point of breaking process trees. Rather than just dropping, Mimikatz to disk and invoking it, directly from their payload or their beacon, they were able to, drop the Mimikatz code into the WMI object, so kind of keeping that off disk, and then invoking the execution through WMI, which actually broke the process tree. So, you normally think evil.exe and Mimikatz right under it in terms of lineage. But in this case, they're having a system process come out of nowhere and execute Mimikatz on their behalf. And then finally, just thinking about, in that same spectrum, you're asked this, this WMI is this whole new, universe. There's different data sources. You think about WMI tracing, that's not going to come from the same places we get, process, command line arguments and all the typical ways that we collect telemetry about our adversaries. But also it's a whole new set of strings. You think about things like, the ways an adversary would typically enumerate, processes or things like that. WMI comes with its own structured, language that is, specific to WMI. So, something like a SOC or analytics might not have already accounted for those particular strings.
Excellent. Thanks, Jamie. Yeah, as a red teamer, I certainly appreciate the living off the land capability. It kind of flying under the radar. So we know adversaries have been using WMI for quite some time now. Christopher, can you tell us a little bit about the history of its adversarial usage?
Sure. So I think one of the Stuxnet in many ways was, kind of so groundbreaking in terms of all the different, 0 days it used and advanced tradecraft. I think one of the areas that actually gets less focus or attention is actually how it used, that also peppered within there was its usage of WMI. It is one of the kind of the earliest examples I can find. But in its network spreading module, where it would exploit a remote system using the Windows Spooler vulnerability, it would then using that vulnerability drop the files to the remote system, and then it would use WMI to then go delete itself and delete those execution artifacts. Using an event filtering consumer, which we'll walk through here shortly. But so it wasn't a persistence mechanism, it was a kind of clean it mechanism. But yeah, this is one of the earliest usages that kind of got a little sub-mention in the original Symantec report. And then ESET also put out a report that about Stuxnet that went into a little more detail about it.
Excellent.
Just from a research perspective, we talked about the original, Stuxnet dossier that Symantec put out. My first personal experience with it was around 2014 with Devin Kerr. We were, doing investigation. We found a file called e.mof, doing some forensics. I had no idea what a managed object format file was. But it turns out it's related to one of the ways that you can instantiate something in WMI and install it into what's called the SIM repository. And so Devin and I, in 2014, we're doing a bunch of research trying to figure out what it is. There wasn't much. Really, the only thing that we could go off of was a 2010 research paper that Trend Micro put out with some details. And so we used that and then had to do a bunch of our own research. And we worked with folks like Matt Graber and Willie Valentin as well. That preparatory work, then I did investigation, a really large investigation that was later talked about by Matt Dunwoody and Nick Carr in No Easy Breach about APT29, and one of the largest investigations and from a tradecraft perspective. And so that early work in 2014 then led to a bunch of the findings and subsequent presentations around WMI. What is it? How does it work? Including the 2015 white paper that around forensics and offense, defense, et cetera. So if you're looking to get a really solid foundation, reading, kind of looking at these different resources, I think would give you a really in-depth look at kind of different ways you can use WMI.
Awesome. And we know that we can use WMI in a number of different ways. You've talked about a couple of those, but let's zero in on persistence.
So I think persistence for me is probably one of the most interesting. It's one of a couple of ways that you can actually, if you choose to, you can actually be fileless, right? You can there's a file on disk called objects.data, or it's referred to as the SIM repository, and you can actually write content into that particular file that you'd have to parse out. So traditional, say, antivirus may not be able to detect or analyze, say, a script that you've installed in there. It also then, so when you use WMI for persistence, there's effectively three components. There's a filter, and the filter you specify using the Windows query language. You can say, when there's a consumer, which is, what you actually want to instantiate or execute when the filter occurs. And then there's a binding that links the filter to the consumer. So there are two different main types of consumers. There's a command line event consumer where you can specify what process you want to execute and potentially specific arguments. So you could use this if you wanted to, let's say you wanted to run encoded PowerShell, or you wanted to run a particular file on disk. You could also use an active script event consumer, which can leverage JScript. And there's various levels of complexity you can do here in terms of layering some of these things together. I've seen active script event consumers where ABT29 created their own class, and then inside of that class is which had the actual JScript code, and then they just from their active script event consumer just called that class. And so you'd actually have to kind of make a couple of different steps to get from the event filter and consumer to the actual code. And then that code would also all be stored in the SIM repository, making it fileless. So you can layer these different pieces together. You can have them fire as often as you want or as infrequently as you want. There's also things from a hunting perspective. You can name them. Each filter gets a name, each consumer gets a name, and binding gets a name. So these are all areas from a hunting perspective that you can leverage to use an environment to kind of baseline itself. So we'll have a couple examples here in just a minute we can walk through.
Yeah, let's look at a few of those examples now.
So these are three examples. So I'll kind of talk you through them. But in your head, as you're looking at this, kind of think through yourself, which ones you think are malicious. They're not all malicious. But so, key things you want to look at would be the name. So the first one, the name is map p filter, and the name of the consumer is map p consumer. It's executing, it's using a command line event consumer to invoke a file in Windows System 32 called gop.exe. The second one, and the first one, the filter, basically it looks for a particular when there's a Windows event log, and that Windows event code corresponds to like connecting to like a Wi-Fi network. So that would be the filter that would kick that one off. The second one is it's basically going to fire once per day. So when the system time is the 20th hour and 10th minute, it will then fire, and so it'll kick off reliably once a day at this particular time. This one actually has more details with it. It's going to kick off an executable. It's going to copy itself to somewhere else and invoke it with regserve32. And the name is Windows Dialog Event and Windows Dialog Consumer. And then the last one is the name is going to be filter one, and the name is sysconsumer1. And it's basically going to kick itself off and invoke a file called program data NVIDIA nvsp-helper.exe.
So number 3 doesn't look too shady, but definitely number 2, a lot going on in that command line template. But quick question about number 1, the query itself is based on not a time, but an event?
That's correct. Yeah. So it's effectively monitoring all things that are being written to the Windows event log. And then when there's a very specific Windows event ID, 5632, then it will fire, the filter will match. And so that's why, that's how you can get really creative in how you invoke these is, as much as you can, as creative as you can be with the Windows query language, you as a red teamer or adversary or whatnot, or even a programmer can leverage that to, let's say you could, the Stuxnet example, they were looking for when you saw invocation of a very specific process name, then take an action. So you can get very creative there.
Yeah, excellent. From a red teamer perspective, I'm just thinking of the things we could do. So I don't know if anybody has an answer out there. You can toss it in the chat, toss it at us in Q&A. But I'm going to show the answers here momentarily. So let's see what those answers are. We talked about some of them, at least a little bit of things that you can look for. So let's take a peek at those answers real quick here. So I don't know if I'm going to give you a couple seconds more, but here are the answers. How about that?
So when I was looking at the first one, I was doing some hunting through telemetry kind of at scale is how I came up with a few of these. And I could have sworn that GOP.exe was going to be something malicious. And I took a bunch of analysis and went through it, and you pulled the metadata of the file on disk and you looked at what else it was. It's totally legitimate, software. It's executable I'd never heard of, but some developer somewhere decided this was a good way to invoke their code when a system connected to a particular Wi-Fi network. The second one is a coin miner. I think that's probably the easiest one to identify from the command line parameters. The third one is interesting to me because the executable that it's invoking, the nvsp helper.exe, if you look at the metadata of the file on disk, it's going to be assigned NVIDIA executable. It's a totally legitimate file. But it's then, in the same directory, you'll have a malicious DLL that it's invoking via DLL sideloading. So when you're doing kind of either triage and analysis of, say, an alert from a product that generated an alert, or if you're doing hunting at scale for these things, there's kind of some key things you can look at. You can use, I like to stack, one of my favorite things is doing frequency of occurrence analysis. So how many systems does this run on, and use an environment to kind of baseline itself. And you can then, because an attacker may not know all the different, they may be able to profile one system, but it's probably gonna be harder for them to profile all of your systems. And so knowing like, okay, well, WMI event filters and consumers aren't that common in an environment. They're, and if they are, it's going to be, you're typically going to need to see the same thing on most systems. Say, there's say like a Dell utility or something that uses it, or HP or something else. And they're going to have the same, event filter, name, et cetera. So if you do frequency and stack either the name, you stack what the filter is looking for, or what it's invoking. Each of those things from a frequency perspective should be able to help you, the least frequent thing should rise to the top. And those are the ones that you would then do further analysis on to see if they're legitimate or malicious.
How often, just a quick question, how often, I think about it from even in just an administrator perspective, how often do we see WMI, not only just malicious, but non-malicious?
So from an event filter consumer perspective, there's going to be a built-in one called the BVT filter and BVT consumer on every single system. And outside of that built-in default one, it's fairly rare. So you'll almost, like if you're looking across an enterprise environment, you're guaranteed to find it. But like I said, there's probably going to be, depending on how large of an enterprise, or let's say you work for an MDR, or you're a consultant doing work at multiple companies, if you have access to telemetry across multiple, you'll find a couple of them, but it's, you can probably count on like one or two hands the types of utilities, and you can, once you see them over and over again, you can, there's not that many.
Yeah, that's kind of what I figured. I like number 3 there because from a investigative kind of perspective, there's nothing in that data there that tells me that that's evil, right? I mean, it's that DLL sideloading. I'm going to have to do some further analysis. Interesting stuff. All right. So now we're going to bring in Matt. So Matt's going to talk about our own challenge. So tomorrow, well, I won't steal the thunder. Matt, go ahead.
Thanks, Greg. All right, so let's put our knowledge to the test here, apply the concepts that we just learned, and put them to practice a little bit, get our hands a little dirty, and see how we might be able to go about detecting WMI persistence. So to do that, we've developed a hands-on challenge to help you set up logging and perform WMI persistence. As you go through the steps, it should be pretty straightforward. So go to the link that you see here, which Brian should be posting into chat here shortly. Copy and paste that. Literally follow the instructions step by step. It's going to run you through setting up sysmon for WMI logging, establishing persistence with WMI using PowerShell from an elevated command prompt, and then submit your answers. So you can submit your answers by no later than 8 p.m. tonight Eastern and 5 p.m. Pacific. So that should give you a little bit of time to run these on your system, do any cleanup that's necessary, and answer some multiple choice questions. Once you do that, regardless of the answers that you submit, not sure if I should say that now or not, but too late. You'll get a Red Canary T-shirt, but give it your best shot, and yeah, that should be a nice token for your hard effort that you put into answering the questions correctly. So tomorrow we'll dive into the results of the challenge, examine and really dig into the telemetry, explore best practices for building effective detection analytics around WMI persistence. So I'll look forward to covering that tomorrow and really getting our hands dirty. So yeah, I'll kick it back to you, Greg. I think maybe we have some time for a couple questions.
Yeah, it looks like we've got a few minutes here for Q&A. Do you know if we have any questions in the Q&A there? I can't quite pull it up.
Yeah, none that are specific to WMI.
I want a free T-shirt.
Yeah,
Someone says I want a free T-shirt in the chat. Taking a peek through the chat here really quick. Excellent. I know we did talk about some of the other techniques, but or at least we focused in on persistence, and we kind of touched on a few of them. What should we look for as far as maybe some other techniques? I know that could be a fairly detailed question, but is there something that we can kind of give some folks or some recommendations that we can make to start looking for these kind of things?
Yeah, I mean, I think, for at least from my perspective, while you may not be able to write, like, say, a high efficacy detection on adversaries moving laterally with WMI, I think from a command line, a very common one that you'll see is like using WMIC to then run on a remote system. Say, you'll see like on the source system, WMIC process call create and then /node, and you're specifying the remote system you want to execute that on. While it's probably not high efficacy enough that you want to generate alert on every one of those, from a hunting perspective, it is very useful to be able to see like, well, who's using that? It's not used very often. If it is, it's probably the same either users or administrators in environment. And if you can kind of understand where and how that's being used legitimately and tune that out, then when adversaries use it, it should stand out more because it is a very common way of invoking code on a remote system, but that many high-skilled and low-skilled attackers use because it's built in to the OS and command line. So.
Yeah, piggybacking on that, I think we see the majority of WMI activity actually in the discovery tactic, which is not really like Graper said, or Glyer. You're not really going to target that necessarily for something that's going to be a high efficacy detection. That's discovery happens all the time. Tracing that's going to be a nightmare. But getting exactly what you said, it might be helpful to benchmark your environment. Look at those those proxy WMI processes that like that WMI privsc. That's a process that's very, it's just the WMI service, and look at what processes are spawning from that and kind of get a good feel for, this is normal. These are things that should be happening versus you see something that like, Mimikat spawning from that. That might be something indicative of, adversary abuse for both local and, remote execution of this platform.
Yeah, awesome stuff. And from a red team perspective, again, we kind of look at it, or when I've used it in the past, a lot of it is for that discovery piece, right? We move into kind of that post-exploitation techniques. We're trying to get a lay of the land, and using some of these techniques allows, at least from a red team perspective, again, I want to differentiate the kind of red team and kind of adversarial emulation type of techniques, again, so that we can detect these things. We use them in that kind of post-exploitation type of way. So a lot of it may blend in as kind of administrator activity or suspicious maybe, but maybe hard to really kind of parse the malicious piece. So again, I'm looking through the chat. Matt, I'll throw it to you to see if you have any questions in Q&A. Otherwise, we might have a couple here.
Yeah, sure. I did see at least a couple come up related to detecting WMI and Sysmon. Now, of course, I'll cover some specific aspects of Sysmon tomorrow. But since we're on the conversation of WMI tradecraft in general, beyond WMI specific optics and Sysmon, one thing that comes to mind for me as a detection opportunity is monitoring process creation for child processes of WMI PRVSE.exe. So that's one of the processes related to WMI execution. And when we're talking about WMI persistence or lateral movement as examples, you're always going to see child processes spawn from that WMI PRVSE process. So will you find false positives in those cases? I can pretty much guarantee that, but that doesn't mean that you can't baseline those in your environment and attempt to find some anomalies there, whether it be suspicious encoded PowerShell.exe, W script, C script, those sorts of things.
Yeah, and in addition to WMI PRVSE, also monitoring for if an active script event consumer has been instantiated, you'll see that with src cons.exe invoking or executing from a process tree perspective would be the other main one that you're going to see.
Awesome. Well, I think we're running just about out of time here. So I did want to talk about making sure that you check out part 2 tomorrow. We're going to dive into some of the challenge results. So make sure you take a peek at that URL that we shared. And we're going to examine and look at some of the telemetry that particular test generates, and then kind of try to come up with some ideas and best practices for looking at some of these detection and analytics. So thank you all for joining us. I want to thank Christopher and Jamie, as well as Matt, for joining us. As always, make sure you tune in tomorrow. And if you have any questions, hopefully we can kind of, you can send them our way. I did show you some of our contact information earlier on. But with that being said, thanks for joining us all. We will see you tomorrow.